All right. So it is, I don't know, it's like 8-ish, a little bit after 8 o'clock in the morning today here in Los Angeles, California. I get up pretty early and I've already taken my dog out and done all my morning routine, fed him, cleaned up a little bit, got myself set up for today. And so I'm gonna just start pulling this stuff apart and I'm gonna see how all this stuff ends up sticking from last night. So here we go. I was going to do a time lapse for this one, but I don't know, it might be, like I wanna see basically, I think they're either gonna pop right off or they're gonna be really secure. So I don't think this is gonna take too long, so I'm just gonna. I don't know if anybody else is a builder or what y'all's background are, but for me, taking off clamps and seeing how stuff's set is like, oof, I've done some like cool stuff. I've done some physics work. So that was the Velcro. There's the thicker elastic. Thinner elastic. And this is for sure stuck, right? So not too bad. How does that mean it's sticking in the fabrics? That's the question. So what'll be a good result here is if I can tug on these things and they don't come off at all, and they stretch the shirt out quite a bit. I'm thinking I'll be able to yank them off at some, like they can't stay perfectly, right? So I think I'm gonna yank them off before the elastic tears or the rubber. So what I'm looking for is whether the adhesive is too weak or whether the material is too weak. That way I know whether I can use the strength of the full material, and if the material does rip, I wanna see if it tears along the glue line. I wanna see how it rips, because if it rips differently, then that means something different is going on. But of course, if you have like a line of glue and it's preventing exactly that line of material from stretching, if there's zero stretch in that material, that's a way that you can mess with physics in a way that I wouldn't want to do, which is, kind of creating a line where energy all hits at the same time and really kind of like just impacts. And so what that does is it enables amounts of energy to reach thresholds more easily for things like, ripping and stuff. So anyway, I'm gonna just start pulling stuff because that's what I came here to do. What should I start with? So I got Velcro, the rubber, and the thinner rubber. So I'm gonna do what I think is gonna break the easiest. All right, let's see here. Oh, and clampies. So, and what I mentioned yesterday about using my machine is if these things don't come off, I might end up going over there, but honestly, that's just gonna be overkill. I mean, if an investor needed me to do that or something, I can do it, but it's just not necessary. Just tugging on this is gonna be fine. This is so cool. This is so like nerdy, but so cool. All right, check it out. I'm gonna tilt you here. All right, so what you see here, oh, this is about to fall over. I'm gonna hold you. So what you see here is I've got three different lines of rubber, and they're each glued with these numbers on it. And so what I'm gonna do is I'm just gonna tug on them and see if it comes off. They're clamped in here. So number one is I've got this all written down, but number one was the fabric, one of the fabric glues. So oh Jesus, that's awful. So that was not good. And then number two is silicone. Okay, that's, Number three is different fabric glue. Oh, thank God. Okay, that's great. So, wow, not the results that I expected. So check this out though. This is great because number one, that was a really clear winner. I'm expecting the same results are gonna happen with at least the thicker rubber, if not the Velcro, but the Velcro that I've got could be really different. And what I also noticed though, so that first one, the fabric glue that's meant for fabric to fabric, it was pretty clearly awful for this. And that's not a big surprise because it just had nothing to cling into. And so because it was purposefully made for fabrics, and it was put on this rubber material, it's that seems to be in line with what the purpose of the material was. The silicone was the second one. What I noticed that I really liked about that was it's very flexible and bendy. So the silicone glue itself is really stretchy. Like when you put it on, it like pulls and makes these like long glue fibers that are super annoying. But it was really high friction, and so when I pulled it up and away, it separated really easily. But when I was pulling it down that way, there was a lot of resistance from it. So with using that glue, I'm fairly certain as a supplementary hold again, right? I'm not planning to use this, to anchor the whole thing, but as a supplementary hold with an additional layer of nylon or like a Velcro strap around it, that silicone glue is going to be really great. I think that's going to be perfect, depending on how I compare it to the other glue. Because it was just easier to put on. And if it's easier to put on than the other glue and it's just as effective with the Velcro around it, then there's no need to use the harder to use glue. But if it's not, then I can use the harder to use glue. So this is exactly the R&D stuff that I wanted to figure out. I'm really excited by that result. Actually, it wasn't what I expected, but God, I'm so glad that last one held on there. So that was a really strong hold. I can definitely yank that off if I want to, but that hold with the Velcro strap is going to be really strong. So let's switch over to the other stuff that I got here. All right. So I don't need to clamp it that much. Let's go for the Velcro. So 1, 2, 3. And I already noticed, so remember how I said yesterday I've left 4 open to the air? And I was going to consider whether they would be good for the underside of the shirt and contacting the skin. Well, number 4 is this material that was made for like grippy socks. So this company made some sort of material, I don't know whether they patented that chemical formula or not, but what you do is you just drop it onto the bottom of your socks and you can make your own grippy socks. And there's lots of reasons for doing that. Friction, God, I'm such a nerd. But yeah, so like that like little material just on the bottom of your socks empowers you with friction. And you can put that on the inside back of your sock heel. Just pro tip, put that on the inside back of your sock heel for no-show socks or just any socks that slip up and down. And the pressure on your shoe against it with that layer in the middle of it and then contacting the skin on your heel, that sock's not gonna slip anymore. So again, just the nerdiness. And so what I realized, or what I found was this first one, the fabric glue, I think material against material, that's gonna be, no, it's not very good. And the silicone is awful. The silicone like makes a really smooth, flat surface, which I kind of wasn't expecting. I thought it would be a little bit stickier, but that was only based on my bias from how sticky and gooey it seemed to be when I was putting it out. So this is not gonna be useful for that. Number 3, the really strong glue, actually that's, yeah, I mean, that's got some real texture to it, so that could be used, but it's soaked into the shirt, which actually could be a good thing too, because that takes less volume. So what's actually much better, so this grippy material that I was mentioning before, it's great. I mean, that, it's a noticeable friction, which is hard to achieve with the thing you stick on with a glue, right? It's got to stick to the materials and then also not dry in such a way that the surface texture ends up being either too soft or too hard to the point where it's resisting it's like not getting any grip. So clear winner for the grippy stuff, for any potential inside of the shirt against the skin, as well as fabric to fabric. This grippy glue that was made for the grippiness clearly is the best. So let's see what happens with the Velcro. So this might have, hopefully they all stick a bit better than the elastic, but let's see. So 3 was the best, 1 was the worst. 1 was the worst last time. Let's see how it does here. Shit. Why is that so bad? I think it doesn't have much to soak in here, but I'm still a little bit surprised that it's not doing better with this right here. And it's still not a word, because with this, what I'm gonna end up doing is I'm gonna be using a sewing machine anyway, and the glue, again, it's a supplementary hold. So that's all I want, but I wanted the easier material to be better. So I think, and I have used that glue before on fabric, so I know how it works fabric. Fabric to fabric, that stuff is great. Boom. So fabric to fabric, I've used this stuff, Fabric Fusion. This stuff is great. This is the silicone that's like a weird stretchy glue. And this is So Glue. This is the stuff that worked. And I'm gonna be just stalking the ingredients list on here to figure out what was up with that. And to see what the chemical interactions might have been, because I really like the chemistry behind this stuff too. And the way that molecules and temperature all kind of work together, and all the bonds, the covalent bonds. So all right, well, so that first one sucked. The Fabric Fusion one really was not good for the Velcro, and it's also, so I can tell that it's secure inside of the shirt material, and it was the Velcro piece. There's no adhesive stuck back here really. And just feeling the surface, yeah, this is, actually none of these are probably gonna stick. This is, so this soft side, it would stick to all of them. This back side is really not meant for any sort of glue to be stuck to it. So I'm expecting these both to come off, but number 3 might stay on okay. Yeah, and again, there's texture there. So let's see how number 3 does. And so if we pull it this way. All right, so that's, oh wow, okay. So that's pulling sideways. Let's see what happens when I pull up and out though. See? So again, this is just physics stuff. And so now I really wish I pulled both the fabric one and the silicone one off not straight first, but it would have been a clear winner anyway. So Glue, this stuff right here. This is by far the clear winner for every application, unless it's, yeah, so it's bendy. Okay, let's see if I can, let's see how much it takes to get this guy off. All right, so that, I mean, that was some really good hold. I stretched this to almost its maximum. And there's no real, oh. So look at that. So I don't know if you can tell, but the material, oh, I guess I cut it wrong. Or I cut it a little bit like that. So scratch that, edit, delete. So really great information. So I know that So Glue is going to be the one that I use. It's stretchy, and I know that I looked that one up. It's made for this too. It's just, I wonder why it's such a better, there's something chemically about it that's much better and more effective than this Fabric Fusion stuff, but it's also more expensive. I think some of the ingredients are probably more toxic when you're using it at first. But of course, once it dries and all that, that stuff really dissipates into the air. You know, you can stick it in the washing machine, unless you're like sticking your nose on it and like snorting the dried up glue, then those toxins aren't really gonna get out anywhere to any measurable or noticeable degree. So, wow, just awesome. So I mean, like I said, it's like 8 or 9-ish in the morning, and I'm just so excited. I've got all day. It's Sunday, but like, I mean, I like doing this stuff. So on my birthday, I spent the entire day, I think, drawing up designs and like writing up a sales pitch. I love this stuff. I'm excited to keep doing it. So what I'm gonna do today is I'm gonna make a pair of jumpy pants. I'm gonna use mostly glue and Velcro, and I don't think that I'm gonna be able to, I'm not gonna sew it in and make it the total permanent device, but I'm gonna make one where I can tell if I can jump higher with it. And I'm gonna start doing that right now. All right, so another of the less fun things already done. So that time lapse, I had to, of course, I mean, I had to take my measurements for a while now, and so I went ahead and I did all that. And I found some really interesting patterns. So I see patterns all the time too, but I mean, these were not exact patterns, but what was weird is like my Adam's apple is exactly on the place on the back of my neck, because I'm doing the front side and the back side, and I found that the two anchor points of relevance are, you know, this bone and the Adam's apple that are the exact distance from the hip hip spot, and the center of the sternum and like the center of the back part, which is going to end up being the back brace or the shoulder component, same distance. And there's a lot of things that are like half of other things, or very close to half of other things. And I think there's something about the golden ratio or something like Leonardo da Vinci's like Perfect Man that he drew. But yeah, I mean, like, I guess I'm noticing some of those ratios, and it's all physics based, and what it's going to have to do with is the length of the bones and whatever the optimum mathematical distribution of energy is, and it's going to have some sort of relationship with like the fact that we have to have muscles and tissue, and that those things weigh not zero and they're pulled down by gravity. So there's some sort of like equilibrium that our bodies have reached, where we've I would assume via about 7 to 8 million years of hominid evolution, we have the bipeds, we've kind of figured out that this is the shape that we want to be, right? We had like Australopithecus afarensis. That was Lucy. I think that was like 2.4-ish million years ago, maybe 250,000 years ago. I don't know. Whatever Lucy was, they were like short. They were like 4 feet tall. So we went through these phases of big heads, big cranial spaces, little cranial spaces, thick skulls, thin skulls. The shape of a creature. I'm getting way into non-physics stuff. So anyway, so I just noticed the physiological structure, doing the actual measurements. There's math there too, and so I love that I'm capturing, kind of the mathematics of what nature has done, and just allowing us to do it outside of the body with like all soft materials. And I did actually. So last night, what I was able to do is I had done a patent search, right? And so I hadn't reviewed the results. I skimmed them before, and it was like everything that came up was not like mine. And so the patent for the TuckBuddy, what I'm calling the TuckBuddy KM system, after my buddy Kev McGuire, who is the one who years ago with me decided that we needed to fix this shirt tucking problem. So that patent is in a bucket in the USPTO office that is like underwear that helps your shirt stay tucked in. So I looked in that. There's nothing that's the same, right? There's only one that I found that had a sandwich concept to it, but it didn't have grip on both sides, and that's the whole point of this whole thing, is the grip on both sides. So I'm pretty sure that patent is going to go through. And this whole system, I can't believe that I might be able to patent this, and that I've got a patent pending on it already. And I looked at everything that this attorney examiner person did in their search that I've also done, came back with everything was like, it required hard pieces or anything that required soft pieces. Like they all had some sort of like electrical circuitry to them, or like hard pieces. And I'm like, you don't need any of that stuff. Like you just don't need it. It's just friction and stretchiness and elasticity, tensile strength, and finding the right anchors in the body. So, a lot of them identify these like they all have different anchor points and like kind of like my system, but none of them just maps out like this is why this is the mapping system. It's because these parts of the skin, the surface area of your skin, are least far away from the bones that are the anchors in your system. And so when you grab onto those specific places, that's why all these devices have the same similar anchor points that I have, but none of them patented and said like, hey, look, this system is it is what's going on. Here's the idea. Here's how you manipulate it. Here's how you make it novel. Here's how you make it do stuff for you that you really want it to do that nobody's done before. So I don't know. So I've got all the measurements done now, and now I'm gonna do another time lapse, probably of me just building this thing and seeing how it goes. Where's my dog? Look at my Bubba. This is Fen, the most wonderful dog in the world, and so the end game. You see what Fen's lying on? So my undying obsession for Under Armour. Ever since I've bought the first Under Armour thing, every single garment has been awesome. So it's why do I love Under Armour? It's quality and consistency. So quality and consistency is going to be my MO, because that's what I like. And so those Under Armour zip ups that are over there, that's the end game. So what I'm going to be doing is I'm going to be working with, I got a bunch of like lower quality, but like nice looking stuff on Amazon that's kind of similar stretchy material. It's like combination usually of, I think, like a spandex and like a polyester blend, sometimes cotton blends. The spandex in there just helps it stretch, and that's just, again, one of the miracles of science and the way that materials can be combined to work together to complement the physical properties of other things that are deficient in something that property has a lot of, like spandex and its elasticity. So you stick spandex in a shirt and all of a sudden, I mean, I'm sure that I actually don't know what is an Under Armour, but I'm sure that it's probably like a 10% spandex type deal. So what was I saying? Oh, so I'm going to be making all these devices with some good quality materials, but when I'm done and I'm slinging these things out to investors, I'm going to have them like embedded inside of these like awesome Under Armour garments that are like, I'm going to want to wear them anyway. So that's the end game. Just kidding. Technically, that's not the end game unless Under Armour wants to do a deal with me where I use their supply chain. The end game is for me to use quality materials and either control the entire supply chain myself or have it licensed out to, like an Under Armour or something. And I mean, there's all sorts of different places that I can license this to, but I can also do supply chain myself probably pretty easily because all it is it's going to be stitching and design. So end game for the prototypes and for the sales pitch and getting investors is these Under Armour things. The end game is the world is my oyster. Check it out. So I don't know if you can tell, but in that time lapse, I was drawing the anatomy of my legs onto these pants and kind of diagramming it out. And so I'm actually, like, at this point, I've got two ways that I can build, well, 3 ways I can build this. Number 1, I'm waiting for a mannequin to come in. I'm hoping that fits really well because it's going to be constructing these things in the way that I want to build them. It's a logistical kind of like a big challenge because I need to clamp them and or secure them to something. And so I think it honestly at this point, it might be the best thing for me to do to put these pants on with some plastic underneath of it and glue this shit while I'm wearing it and clamp it while I'm wearing it. That would be really uncomfortable, and I think that I can get away with doing it on this table. So I'm gonna try on the table first because that will be a much better, if I can make that process work, that will be much more effective for the next week and a half or 2 weeks that I'm waiting for this stupid mannequin to come in. I might drive to a department store or something and see if I can get something, or to like some place that has these things, because like I said, I've got to basically stretch elastic so it's taut while these pants are getting on, and then I'm gonna have people strap that ankle to the legs, pull the pants up, strap the anchor to the below their knee, pull their pants up, strap the hip on, and then that thing will be a spring system. But yeah, so yeah, time lapse coming up. Here we go. All right, so I'm actually pausing that time lapse to say, wow, so I keep scraps from everything. Obviously, I try to like keep stuff left over because I never know what's gonna come in handy. And check this out. So you saw me sanding that piece of wood, I think in that time lapse that I'm gonna put before this, and it's perfect. It's exactly what I need. It's gonna be better than the mannequin. It's gonna be better than my leg because it's straight. And straight and flat. And I found a piece. I have a bunch of scraps, but I found one piece that's exactly, like literally, it's like perfect. I couldn't have like pre-cut. I mean, maybe I would have added an extra like 4 inches to the end of it. That's it. Irrelevant. Maybe not, because it's the shorter distance is better. So anyway, so I've got I'm probably gonna end up canceling that order for the mannequin and seeing if maybe I can get one just for the top. Well, no, I'm still gonna need the whole thing when I'm making the full body suits to make some adjustments there. So that's in the future, but I'm just not gonna have any delays now, except for the top stuff. Like I can make the leg stuff with just this one piece of wood. So we're gonna go with that. I mean, that's how this is how I want the physics to be, is to be this. Like, this is mathematically better than your body, really, right? So this straight line up and down, like, this is better than the curves that we have in our body, these straight lines. But the reason that our spine curves is because we don't want to snap it in half if we accidentally hit a critical point, right? We want it to be able to bend and flex. But mathematically, this is what we want for like optimum power. That's why concrete structures, pillars are completely straight up and down. So I want the forces that are being imparted on your body to be this, and then I want them stuck to your body and pulling you towards this. So, God, it's just gonna be so much better than using that dummy. And yeah, I'm gonna cancel that order, and I'm just not gonna I'm gonna be able to use this. I'm gonna be able to custom cut my own boards because I already have all that material like left over. So, gosh, this is gonna be kind of fun, kind of meh, but I'm gonna be able to make like custom sized cutouts for doing my project. So that's what I'm gonna do instead of building it today, because that is gonna just jump my quality up so freaking much. And the speed at which I can do this, I mean, like, I'm gonna be cranking out like, one complicated one a day. One complicated one because I'm gonna only have enough to like have one thing stuck using up the templates. But if I make more of those, and I can just, God, I'll be able to crank these things out pretty quickly by myself. So anyway, that's what I'm gonna do, is I'm gonna start building these templates for out of wood, and we're gonna go from there. So that is going to be, I think, the perfect size for these medium shirts that I've got.